All right, today's lesson is chapter 9, lesson 6, permutations. All right, chapter 9, lesson 6, permutations. So we're going to go over what this word means and how you can kind of remember it. And hopefully, there's part of it that's a little bit confusing, but hopefully we can do okay with it. So, first of all, what is a permutation? Okay, and in the word permutation, you have the word mutation, right? And if you think of mutation, you think of like all the different things that something can mutate. Something could have, grow an extra limb, or like an X-Men, like different powers. That there's all these different powers, all these different things that could happen, right? So in a way, permutations is like that, kind of, not super, but not super close, but it's the idea of how many different ways can things be arranged? How many different ways can you organize a group and put them in a certain order? Okay, so first let's talk about just like a definition of a permutation. I'm sorry. Think of it as like all the different orders things could be in. So far in probability, we've talked about just all the different possibilities, and this is true too. We're looking at just what are all the different possibilities, but permutations are different in that there's a certain order that things need to happen in, and we'll go over some examples here. So, and that's why it's again, we're also with probability. You need to know the total. You need to know the total amount of everything that could happen. Um, but with permutations, again, there's kind of certain rules and stuff. So let's do an example. Let's say we're having a race. Okay, let's say that we're having a race and we had three runners in our race. Let's say um, let's say Jared, Timmy, and Billy were in a race. So the question is, how many different ways could these three people finish? How many different ways could they have? So um, we could think of it as, okay, well, like how many different ways could they finish, right? So that's the question. So how many different ways or permutations could they finish, right? So let's just do it the slow way. Let's just kind of list them all out, right? You have to kind of imagine uh, that they're in this race. So first, we could have Jared could win, right? We could have Jared could win, then Timmy could come in second, then Billy could come in third. Well, or you could have Jared could win, then Billy could come in second, then Timmy could come in third. Or you could have Timmy could finish in first, then Jared, then Billy. Timmy could finish in first, then Billy, then Jared. And then you could have Billy could come in first, then Jared, then Timmy, or Billy could come in first, then Timmy, then Jared. Now, you could do it this way. You could list them all out. These are the six. There's six different permutations. So we would say this has, okay, six, right, permutations. There are six variations to their finishing order. Okay, six permutations. Now, wouldn't this be a pain though if you had like 20 people in the race, right? That'd be hard. You don't want to have to list them all out. So, luckily, there's a better way to do this, a more mathematical way to do this. And really, it's quite simple. Think of it this way: how many people could get first place? Right? Well, Jimmy could get first place, Timmy could get first place, and Billy, well, they could earn first place. So there are 3 people that could earn first place. Now, how many could earn second place? Now, you might be tempted to say, well, 3 people could. Billy, Jimmy, and Timmy and Jared, they could all win second place. But really, actually, think of it. If somebody wins, it gets first place, there's only 2 people left to get second place. So it's actually 3 people get first, and only 2 people could get second, right? Because assuming that, let's say, Jared gets first, then there are only 2 people left to get second. And that means how many people could get third place? Well, if the first 2 are already decided, then that means that there's only 1 person left for here. And so what do you do with these numbers? 3, 2, 1. Well, all you're going to do is multiply. 3 times 2 times 1 is 6. So there are 6 permutations. I didn't have to draw them all out. There are 6 different ways that they could all get organized. Let's do another example. Let's say that you were going to do a survey, okay, of favorite fruit, right? Let's say you had orange, strawberry, let's say kiwi, and grapes. There's lots of other fruits, but we'll just say these 4, okay? How many permutations are there for the order of your survey? Okay, so oops. So let me make sure I spell that correctly. How many permutations are there available? If you were going to put these in order, okay, from least or the most liked to the least liked, how many different permutations would there be? Okay, so again, you can do the same thing, right? You can think about it. How many different fruits could win first place? Could be the first in this order. Right? Well, there are 4 choices: orange, strawberry, kiwi, and grapes. So there are 4 choices for the first spot. How many choices are there for the second spot? Well, if let's say orange got first, there's only 3 left, right? So there's only 3 left. How about for the third spot? Well, there's let's say orange got first and strawberry got second. Well, how many are left? Well, that means there's only 2 remaining. And in the last spot, there's only 1. So 4 times 3 times 2 times 1, right? Do that in your calculator. 4 times 3 is 12, times 2 is 24, times 1 is 24. So there are 24 different permutations. Okay? There are 24 different permutations, 24 different ways that you can organize these fruit. Right? And again, why does it have the number go down? Because you can't have orange and then orange again, right? So there's not 4 choices for each. It's like that. It's not like that, right? It is 4 different, or sorry, there's 4 different fruits, and it goes decreasing. So 4 times 3 times 2 times 1, 24, and then just multiply. Let's do another example. Let's see. Let's do another race problem. Let's say 7 people enter a race. how many permutations, how many ways can there be for just first and second place? Okay. How many different options are there for I don't care about everybody finishing. I just want to know for first and second place. All right. So what you want to do is you want to take a look and you say, okay, well, 7 people can enter the race. So how many people could win first? Well, if it's truly a race and people are all running it, then technically everybody can win. 7 people could win first place, right? And how many people could win second place? Well, somebody won first, so you don't have 7 choices again. You only have 6 people that can earn that one. Now you might think, okay, now I go down to 5 times 4 times. No, but remember, I'm only worried about 2 places, first and second. So what I want to do is I'm just going to multiply 7 times 6. So there are 42 ways that they could finish. 42 people, only let's say only first and second get medals, right? There's 42 different possibilities for how people get medals. So the difference with this type of problem is that you do not go all the way down to 1. You only go with how many spots you're looking for. Right? So really what you're going to do is it's basically you always take the top one, the one with the full amount of people, right? Or the full amount of fruit or whatever it may be. That's the first one. And then you go to as many spots as you need, right? Sometimes it goes all the way if it asks for all the different things, right? Or it might stop and say, okay, well, I only want the first 2 spots, or I only want 2 things, right? So let's just do maybe another example or two so we can kind of look, right? This one will be really practical for you. Let's think about it, right? Your class schedule, right? You guys have you have math, language arts, history, science, PE, and your elective, right? So how many different ways could your schedule be, right? How many different ways could your schedule? How many different ways? You're like, okay, oh, I really want PE first period. I really want math second period. Like, how many different ways could your schedule happen, right? How many different things could happen? How many different ways could you organize your schedule if you have 6 classes, right? So math, science, language arts, history, PE, and your elective. So you're looking at 8th grade coming up next year. I want to know what my schedule is going to be. You know, I really want my same exact schedule with my best friend. What's the probability that we're going to have the exact same schedule? Right? And not counting homeroom. Okay, just the subjects. Okay, so how many different possibilities can I have for 6 classes? Now I didn't say just for the first 2 classes. I said for all 6. So let's do all 6, right? How many different ways for first period? I can have 6 different choices, right? For second period, that leaves me with 5. Third period, that leaves me with 4. Fourth period leaves me with 3, then 2, then 1, and I'm going to go ahead and get my calculator and multiply all that together. Okay. So you should have gotten 720 permutations. There's 720 different ways that your schedule could be organized next year. Now, if you have a certain elective, this is assuming that, your elective isn't set on a certain period or whatever. Let's say your schedule just completely open for any elective. So you'd have 720 possibilities. So the question is, the question was, what was the probability that you would get the exact same schedule as your best friend? A 1 in 720 chance, believe it or not. And that doesn't even account for the different teachers. Like, you could have the same schedule but have different teachers. So there's, it's not very likely that you'll have the exact same schedule and with all your friends, but sometimes I know it works out where people have very similar schedules. So um, if I was asking this exact same question, but I only said, how many different possibilities for my first two classes, right? So if I wanted this exact same question, but I'm saying for only the first two periods, period 1 and period 2, again, I would not go all the way from 6 down to 1, but in in this scenario, right? How many different things could I get for period 1? Well, I still have 6 different options. And for period 2, I have 5. So the probability of me getting the same exact class as me and my best friend for the first two periods, a 1 out of 30 chance. Okay, not too bad, right? Not too bad. So again, you start with this the big number is what you start with, right? The 6, what you start with. But how many you want to go down? If it's talking about all 6 periods, then you have 6 spots. Period 1, 2, 3, 4, 5, and 6. If you're only talking about 2 periods or 3 periods, then you only go as far as you need. And those are the two different kind of questions you're going to see on IXL. As you get harder, they just do these ones where you only have to go 1 or 2 spots, right? And the easier ones, again, you start with kind of like these first two questions, A and B, where you say, all right, well, let's just start from the top and work all the way down to 1. Okay. So again, permutations are just all the different ways that all the different possibilities when you're trying to put something in order. When there's an order matters, where things can't be repeated, right? So, if you're doing a race, Jared can't win first and he can't win second, right? He can't win first and second in the same race. You win first. If you win first, then you're not, you move on. So that's why it goes down from there. It's just how many things are possible, and then you multiply them, right? And that's a good trend for probability in general. Think of what's probable, what's possible for each step of the way, and then multiply them together, right? So if you're looking at this, right, again, there's 3 possible for the first, which leaves only 2 possible for the second, which leaves only 1 possible for the third. Multiply them all together, you get 6 spots, right? There are 4 fruit to start with. Then 1 gets first place, so that means there's 3 left. Then 1 gets second place, so there's only 2 left, and then there's only 1 left. There's 24 total permutations. Okay? And then lastly, we look at these ones where sometimes you only need first and second place, so you only talk about 2 spots. Again, still starting at the top and still multiplying. Right? So that's a quick little lesson on permutations.